Hello everyone, today in this beam we are going to derive the expressions for slope and deflection using the conjugate beam method. This is a simply supported beam subjected to a clockwise concentrated movement m in the center. This beam we have already analyzed for shear force and bending moment. Also we analyzed for slope and deflection using Macaulay's method. There is a link in the description. You can click the link and watch the video. RA will be acting downwards and RB will be acting upwards. Anyway, we are not going to need both of them. We need only this diagram. If you wanted to know how this diagram comes, as I said earlier, you can click the link and watch the video. Left of the center we have negative and right side of the center we have positive. This is the conjugate beam. I have kept the loading in the negative side downwards and in the positive side upwards. We have to divide the moment by EI. To find RA dash, let us take a moment about B dash. In this case, we have to follow right hand side rule. RA dash is acting in the anti-clockwise direction, so it will be negative and the distance is L. Let us take the left side UVL. It is acting in the anti-clockwise direction, so it will be negative. We know that for the UVL, we have to multiply the area with the centroid distance. Let us take this triangle. We know the area formula half into BH. Here the breadth is L upon 2 and the height is M upon 2 EI. So this is the area. The centroid distance about C dash is 1 upon 3 into breadth. Here the breadth is L upon 2. So this is the centroid distance. We are taking moment about B dash. So we have to add the remaining distance which is L upon 2. Now let us take the right side UVL. It is acting in the clockwise direction, so it will be positive. Now let us take this triangle. This is the area and the centroid distance about B dash is 2 upon 3 into breadth. Here the breadth is L upon 2. So this is the centroid distance. After simplifying for RA dash, we will get a negative expression. That means the assumed direction is incorrect. We have assumed RA dash would be acting downwards, but actually it is acting upwards. So we have to change the direction. You can see that I have changed the direction of RA dash. This loading is acting downwards and this is acting upwards. So when we apply the rule sigma v is equal to 0, both of them will be eliminated. In this case, RA dash and RB dash will be same, but they will be acting in the opposite direction. RA dash is acting upwards, so RB dash should be acting downwards, but both of them should be same, ML upon 24 EI. Using the right hand side rule, let us find the shear force at A dash. It is acting upwards, so it will be positive. Now let us find the shear force at C dash. It is acting upwards, so positive. The UVL is acting downwards, so it will be negative. For the UVL, we have to take the area. We know the area of this triangle. Finally, we will get this. Using the left hand side rule, let us find the shear force at B dash. It is acting downwards, so it will be positive. We know that these are the slopes in the real beam in the points A, C and B respectively. Using the right hand side rule, let us find the bending moment in the center, which is at C dash. This is acting in the clockwise direction, so positive, and the distance is L upon 2. Let us take this UVL. It is acting in the anti-clockwise direction, so it will be negative. This is the area of the triangle and the centroid distance about C dash is 1 upon 3 into breadth, so it is 1 upon 3 into L upon 2. For the bending moment in the center, we will get 0. So in the real beam, the deflection in the center will be 0. Now let us make a section XX at a distance of x from A dash. We need to find this height. For the distance of L upon 2, the height is M upon 2 EI. So for L upon 2, it is M upon 2 EI. But we need the height at the distance of x. So we have to multiply with the x. In this way, we will get the height as mx upon EIL. Using the right hand side rule, let us find the bending moment on the section. This is acting in the clockwise direction, so positive, and the distance is x. So we will get this. Let us take the UVL. It is acting in the anti-clockwise direction, so it will be negative. We know the area formula half into BH. Here the breadth is x and this is the height. So this is the area. The centroid distance about the section is 1 upon 3 into breadth. Here the breadth is x. So this is the centroid distance. After simplifying, we will get this expression. So this is the expression to find the deflection in the real beam at the section. But we have to be very careful. This expression is only applicable from the left end to the center. Now we are going to find the maximum deflection. We know that slope will be 0 in the point where there is maximum deflection. From this expression we can find slope. We have to differentiate this with respect to x. For x it will be 1. For x cube it will be 3x square. We can take this term on the other side. It will come inversely. When we multiply that with 0, it will become 0. We can take this term on the other side, so it will come as positive. For x, we will get L upon root 12. To find the maximum deflection, in this one, instead of x, we have to apply L upon root 12. We can write x cube as x square into x. We know that x square is this one and x is this one. We can eliminate this L and this L. From these two terms, we can take L square upon 4 root 12 outside. 1 minus 1 upon 3, it will be 2 upon 3. We can cut 2. Here it will be 12. 12 into 3, it will be 36. We can write root 12 as root of 4 into 3. We can take 4 outside. So it will be 2 root 3. 2 into 36, it will be 72. For the maximum deflection, we have got a positive expression. That means the deflection occurs upwards. If you wanted to find the deflection in the real beam from the point B to the center, this is the expression. We have to just add a negative sign in the previous expression. This is the elastic curve. In the midpoint, the deflection is 0. There will be two maximum deflections. On the left side, it will be upwards. And on the right side it will be downwards. Now we are going to end this session. Thank you for watching this video.